application. Number 4 is from from Nvidia. Marianne, do you want to use this?
Yep. Thank you. So today we want to present to you a case of distributed Orchagent. Give you some motivation and some of the things that we added to SONiC to enable this thing working. So first of all, why do we need it? SONiC today has a monolithic Orchagent process, which is built along with the SONiC image, and a new feature or app extension that needs to program new SI functionality requires making changes to existing Orchagent and building new image, or at least upgrading the SWSS Docker. Distributed Orchagent would enable an extended orch running as a separate process outside Orchagent, and this can run as a separate Docker as well. So it simplifies the process of software upgrades in SONiC, extensions, experimenting, debugging, etc. Running an orch outside of Orchagent will require additional infrastructure such as FDB key to SI object mappings. Orchagent publishes the mappings between application DB key and SI objects in a state DB table. This is what we implemented for this presentation, and we have a demo app running together with Orchagent. Yeah. So this is kind of the essence of our work. We were trying to add FDB to SI object ID auto labeling. So the key thing here is that we don't need to do any manual job for Orchagent itself. Everything is hidden underneath. So we are trying to marry two databases, basically FDB and ASIC DB, and provide some insight between them. So when Orchagent is running, we kind of hijack the consumer and we update what is the latest FDB key that is processed by Orchagent. And we also wrapped a little bit SI helper to record every object ID created under that key, so that OID mapper consolidates this information, writes it to state DB for external processes to use. So this doesn't need to have any impact on performance, by the way. The recording itself can be batched, saved, and written to the database whenever Orchagent is free. And it has also additional benefits that I will get to later after the demo. So this is the usual sequence diagram. We have Orchagent syncd and state DB as a common actors, and then some extended functionality added on top. First, we just program SONiC as usual. We create some FDB entries. It will trigger creating the objects. This will lead to the update in the state DB. We can subscribe to whichever keys we want, and then get the required information via notification. Then we utilize the already present channel for Orchagent. Actually, it's SI-Redis that allows us to remotely program SI entries, and this whole thing gets into syncd. So we have the context needed from Orchagent. I will show the example of that, and we kind of plug into Orchagent without actually the need to change the process. And the demo. So the demo will present a case for ECMP distribution statistics, basically ECMP stat, new command, new functionality. Next top group is created with its members in Orchagent itself. So we use the vanilla SONiC for that. We load our ECMP stat app extension to listen to the needed key in state DB, and we create a generic counter, attach it to the members, and then when we print out the statistics, we have all the needed information, like which group and which members are we talking about when we are reading the statistics. So this information will come from the mapping. So this is a setup. We have a switch. We have kind of imaginable set of firewalls behind which we have some of the IPs that we really try to reach. So we have two groups, 3 members in each of them, and like 2 routes that we try to reach. So the demo. And I will also emphasize on the additional benefits that we get from this auto labeling. Why is it not playing? 1 second. All right, can you see that? Okay, so yeah, it's 2.5 minutes. So basically we're running SONiC in here, vanilla SONiC with one thing added. As I mentioned, we have FDB auto labeling as part of this image, usual set of Dockers, nothing special. So for example, like what we get just out of the box now that we have this context in the database, like whichever entry we create, in this case, for example, VLAN, we have also the object IDs associated with it, like VLAN itself, VLAN members, all that. So we can understand which VLAN member in FDB maps to which object ID inside for that thing. So next thing we do is we load our extension. So we use the app extension infrastructure for that, basically loading another Docker that's running a light version of Orchagent that's just doing one thing. We enable that. That's common stuff in SONiC. Didn't need to do anything for that. So now we have a new Orchagent running, which is sub Orchagent, which is doing one thing. It's attaching counters to our ECMP groups that were configured before for the static routes. So we add all of the config, we add the groups. We can see the results now. So this is how it looks. We have, what do we have here? We have 2 groups added. Like first one is the FDB. We see one group, NHG1, another group, NHG10, and all of the additional information, what are the members, routes using them, etc. And all of that mapped to, now we print the state, the portion of the state DB. We see that all these NHG groups are mapped to the group ID itself plus members. So we can distinguish by the object types. And we can run statistics. So now everything is 0. We can run some of the traffic to hit those routes, and we see a distribution over here. And nice thing that like we can understand what's going on from this auto labeling, that this is next of group 1. We can get the members from it, and basically correlate this with the configuration in FDB. Yes, so, and by the way, everything is dynamic. So if we do any changes, these contents of this mapping will be updated as well. So now we added a few more members, and we will automatically see them because we are subscribed to changes in this mapping as well. So yeah, more data in here. We can read those. We can attach more counters like that. So basically, yeah. So quite easy to use, dynamic, and basically the idea is that we can provide an easy way to improve on the Orchagent in some local places with some additional features without basically rebuilding everything. In addition to that, another benefits are that this information is available, can be available at all times, so we can view it without needing to like GDB attached to the Orchagent process. We can see all of this insights of the Orchagent. Plus, we can export it to the tech support as additional information to not have to correlate between FDB and ASIC DB manually. So yeah, that's it.
Do you kind of use this to decouple the existing agents?
Yeah. So we can kind of split Orchagent into Orchagent functions into two pieces. One, some of them are like core functionality. Some of them is more like a satellite, S-Flow, for example, other things that live on their own. And it is completely possible to split Orchagent, and yeah, we intend on doing that.
Maybe just allow me to drill down one more step, right? For the things that is somewhat decoupled, might be easy, but let's say the router and the interface, those things are very coupled. Then, do you think that's a same technique can be applied?
Maybe not. So I don't think that we can now do all of the Orchagents as separate processes. This will be more complicated, especially if there is some lazy initialization, other stuff involved. But if we have some simpler case that nothing depends on this feature and it's usually mapped one-to-one, no lazy initialization, then we can easily do it as a separate process. And I think like a nice thing to look at it is SONiC has this feature table. So basically features would be the like S-Flow, as I mentioned, would be the first candidates to be decoupled from the Orchagent.